All right, hi everyone, and welcome to a super quick review of one of your favorite topics from the last few years, SOH CAH TOA. And believe me when I say this is going to be quick. This is meant to be a real brief review. I do have some more thorough videos posted on my YouTube page if you're looking for something more in depth. Okay, just wanted to give you a refresher on what to do in this situation. If you're handed a triangle and you're looking for a missing side, a right triangle, I should have specified. It's got to be a right triangle. You're looking for, I don't know, let's say this side, and you're given one of the angles, so let's make this like 36 degrees. Okay, and let's see, we do need one more side length, so let's get the hypotenuse in here. Let's say the hypotenuse is 12. Okay, so in a scenario like this one, first thing I always do is identify the angle that you know. All right, because everything you pick from there on out is based on the location of that angle. Okay, based on that angle, this would be the adjacent side because it's right next to it, and this one here, because it's across from the 90, that's the hypotenuse. That one's the hypotenuse no matter which angle you're looking at. Okay, always across from the 90 is the hypotenuse. And just for the record, we're not going to use it in this particular problem, but this would be the opposite side from that 36 degrees. So if I had had my number or my X down there, I would be using the opposite side. But I don't. I'm working with the adjacent and the hypotenuse. So based on our SOH CAH TOA acronym, adjacent and hypotenuse, that's going to be the cosine ratio that I'm going to set this up with. So my problem is going to set up like this. Cosine of, and it's always cosine of the angle, so cosine of 36 degrees equals, and this is saying that we should always do adjacent over hypotenuse, so that would be x over 12 in this case. Okay? And the way I always go about solving these, and everybody does this a little bit differently, but I always think of this as being over 1. I don't know that you necessarily need to write it, but think of it that way. And then I cross multiply like a proportion. And again, you probably can get away without writing all of this down every time, but just wanted you to kind of see my process. So what I end up with is 12 times cosine 36 is equal to x times 1, or just x. So really in this case, I've got x by itself already, and all I really need to do is evaluate this. 12 times cosine 36, which can go straight into a calculator, and I ended up with 9.7. And looking at my triangle, that seems pretty reasonable. Okay, now one quick thing I will say. I've had some people in the past say, why do you bother with all this proportion stuff? Why don't you just say when you have it like this, you multiply 12 times cosine 36? If this comes out the other way around, it doesn't work out this nicely with the x over here by itself, okay? And so if that's the case, it's going to end up being a division problem, and some people have done this so many times that they've kind of figured that out. But you've got to look out for that, and I find that sometimes people get lost there. And so if you always have this set up to fall back on, whether it's multiplication or division, once you do this cross-multiplying, this equation is going to kind of set itself up to be solved, okay? So I kind of always fall back on this. If you can do it, in a shorter way, if you can do it, by just knowing whether to multiply or divide, that's totally fine. Okay, trying to keep this one under 5 minutes, so I'm close here. Next up, I'm going to talk about using this SOH CAH TOA stuff, but to find a missing angle instead of a missing side. So here we are back again. I'm planning to make this little segment short as well. I'm going to still talk about SOH CAH TOA here, but instead of using it to find a missing side length, which is what we did in the previous piece, I'm going to use it to find a missing angle. Okay, so we'll go back to our same triangle. It's got to be a right triangle for SOH CAH TOA to work. Let's say I give you 2 side lengths. Let's say I give you that this side is 8 and this side is 15, and I ask you to find the measure of this angle here. I guess technically I should have used a theta, but I wasn't sure theta would fit. So, kind of using the same logic we had before. This is the angle I'm focusing on, so I want to make sure I'm paying attention to how these side lengths relate to that angle. And based on that angle, that's an x degrees, by the way, this would be my opposite side. And then this one's across from the 90, so this would be my hypotenuse. So working with O and H has me working with the sine function. So I'm going to set this up as sine of, and it's still of the angle, so I'm going to say sine of x, oh my handwriting just got really bad, equals opposite over hypotenuse, so that would be 8 over 15. And then to get rid of sine, to cancel out sine and get x by itself, what we're going to use is called the inverse of sine. And on your calculators, it's generally up above the sine key, but it looks like this. Sine with a little -1, so usually you're hitting second sine. And then you're going to type in this fraction that we set up over here. So 8 divided by 15. Second sine, 8 divided by 15. And I come up with 32-ish degrees. Okay, so in any trig problem, okay, for forever, any trig problem that you ever do, whether it be law of sines and cosines, whether it be some of the more complicated stuff we're going to get into next, anytime it's an angle measure that you're trying to find, anytime it's a missing angle measure, you're going to end up using the inverse function. Inverse always leads you to an angle measure. Okay, so it's really important that you kind of make that connection. Okay, but that's really all there is to that. Obviously, if you had a different combination of side lengths, you would use a different trig function, but otherwise, it works that same way every single time.